Okay, back to the classroom, grade 8s. By the way, I'm going to ask you to pause and do something in just a couple of seconds. But before we get to that, we've taken some major steps here. We've gone from understanding what pi is to going over how to determine circumference using pi and the diameter and all that other kind of stuff. Today, we're going to take it one more step further. We're going to take a look at how to determine the area of a circle using just the diameter or the radius and the use of pi. Okay, so one of the things you may have to do today is take a little bit of a note or two about the formula we're going to be using. Okay, it's on its way. But first, I need to talk to the people in your house. So here's what I want you to do. I'm going to count to 3, and I'm going to say pause. And I want you to pause the video. Go get your parents. Go get your mom. Go get your dad. Go get whoever's at home who's in charge. Bring them to the computer and let them see what I'm about to say. Then we'll continue. Are you ready? 1, 2, 3, pause. Okay, we're back. I want to give a personal invitation to everybody to join us at tomorrow night's open house here at SGEM. We get underway at 6 o'clock, goes to 7 o'clock. We're going to spend some time in the gym, then come on up here. It's a great opportunity for us to touch base after last year and go into our new year, see our new classroom, talk about some new resources that are that are available, and basically just touch base and reestablish our communication between yourselves and me as the year gets underway. All right? So that's tomorrow night between 6 and 7. Once again, it gets underway in the gym that moves up to the classroom. There's pizza coming, there's a barbecue available, that kind of stuff. But more importantly, it's a good chance for us to say hello to each other. Okay, once again, that's tomorrow night, 6 till 7 here at SGEM. All right, you can pause it again, give it back to your son or daughter, and we'll get on with the math lesson. Okay. Okay. All right. So here's what we're doing. How can you take a look at a circle and determine its area? It's two-dimensional space that it takes up just by taking a look at a couple of small measurements, most notably either the radius or the diameter, and knowing how pi works. Well, we're going to do just that, all right? So let's get ready. Here we go. Okay, here's where we're going to start. What we need to do is figure out how much space this takes up. What is the area of the circle? And there is a way of figuring it out, just as we had a formula to figure out what pi was to begin with, right? Circumference over diameter. You can figure out what the space is in here simply by using pi as well. Archimedes was not a stupid man. He figured out a lot of things, and this is one of the things he figured out. In order to figure out the area of a circle, you first need to know either the radius or the diameter. Now, it's easier to know the radius because what the actual formula is pi r2. You take pi, you multiply it by the radius squared. Okay? So in other words, the equation would look like something like this. If this was a 5 centimeter radius, the equation would look like this. 3.14 times the radius, which is 5 centimeters, right? But it's not just 5 centimeters, it's 5 centimeters times 5 centimeters, okay? So let's see how that works out. 3.14 times 5 centimeters times 5 centimeters, that's 78.5 centimeters squared. Remember, we're talking about area, so now we're talking about square centimeters. Do you want to go over that again? One more time, okay? So in other words, if you're trying to figure out the radius of a circle, not the radius of a circle, the area of a circle, you have to start off with the radius. You take pi, 3.14. You multiply it by the radius, but not just the radius squared, right? So it's the equivalent of 3.14 times 25 centimeters, which equals to, how much again? 78.5 centimeters squared. Okay, let's see if we can work a couple of these out and see if we can figure this out. If the radius here, if the radius is 2 centimeters, then what is the answer? Okay, if the radius is, if the diameter is 1 centimeter, what's the answer? If the diameter is 5 on this one and 1.5 for the radius here, what are the answers? If you need to, pause here and see if you can work them out. If you don't, we'll move on. But I'll give you another 3, 2, 1 countdown. 3, 2, 1, pause. Okay, if you've worked them out, great. Okay, so basically, there we go, and there we go. Let's see what the answers really are. Okay. Oh, wrong way. Sorry, we went the wrong direction. If it's 2 centimeters the radius, the answer, 12.6 centimeters squared. So again, 3.14 times 2 times 2 is 12.6. But if the diameter is 1 centimeter, that means that the radius is what? Yeah, it's 0.5 centimeters. Or, no, let's leave it at that, 0.5 centimeters. So it's 3.14 times 0.5 times 0.5, and that is 0.08. If the diameter here is 5 centimeters, that means the radius is what? 2.5? So 2.5 times 2.5, then multiplied by 3.14 is, if I can get this down here, 19.6 centimeters squared. It's really important that you put the square in there. And the same thing here, if the radius is 1.5, that's 1.5 times 1.5 times 3.14, which is 7.1 centimeters. Okay, so let's get an idea of what we can do to figure this out. If I take the ruler and I measure just how many centimeters this is apart, okay, this is a 6 centimeter, approximately 6 centimeter diameter. What's the radius? Yeah, 3. So 3 times 3 is 9. 9 times 3.14 should be our radius, our area. Okay. Same thing with this one. This is 1.5. This is 4. This is 3. Okay. So if I drag this to the target to reveal the answers, there's the answers. Okay. 1.8 units. Let me get this a little over here because we don't know quite if they are centimeters. We're going to use units instead. 1.8 centimeters, or 1.8 units, 12.6 centimeters, 7.1 units squared, 28.36. This is not a difficult formula, but really it can be used in an awful lot of things, right? Think of the area of that's covered by a swimming pool in your backyard if you've got a round swimming pool, that kind of thing, all right? So we can also do things here that we can get things done. If your radius is 4 centimeters, what's the diameter? 8 centimeters. What's the circumference? Yeah, messed you up, right? The circumference is 25.1 centimeters. Why do we know that? Yeah, you know it. If that is that, what is the area? 50.2 centimeters. Strangely enough, the area is double the circumference squared. Same thing, if the radius is 3.5 and the diameter is 7, doubled here, the circumference is 22 centimeters. Give a thought of what the area happens to be if the circumference is 22 centimeters. No. I know. It doesn't always work out the same way. But think of it. If you can work this out, you not only know the circumference, you not only know, I know, I was trying to catch it. You not only know the circumference, you not only know the radius, the diameter, you not only know how much space is on the outside, but now you know what's on the inside. Do the assignments that are with it. We'll talk about this tomorrow and go through it in detail. Good luck.